Saturn, the ringed planet Little Shaver World. Learning objectives. Identify and describe Saturn's key physical characteristics including size, mass, gravity, and rotation period. Understand the composition and characteristics of Saturn's atmosphere and surface. Identify and describe Saturn's moons and rings. Saturn. Saturn, the sixth planet from the Sun, is renowned for its stunning ring system and is the second largest planet in our solar system. As a gas giant, Saturn's composition, atmospheric phenomena, and extensive system of moons make it a fascinating subject of study in planetary science. Orbital characteristics. Distance from the Sun, approximately 1.4 billion kilometers or 886 million miles. Orbital period, 29.5 Earth years. Rotation period, approximately 10.7 hours. Axial tilt, 26.73 degrees. Orbital inclination, 2.48 degrees. Physical characteristics. Diameter, 120,536 kilometers, 74,898 miles, at the equator. Mass, 95 times that of Earth. Density, 0.687 g/cm superscript 3. Atmosphere and surface. Saturn's atmosphere, composed primarily of 96% hydrogen and 3% helium, is characterized by dynamic weather patterns, including powerful storms and high-speed winds reaching up to 1,800 km per hour or 1,100 miles per hour. The upper atmosphere features alternating bands of clouds, with hues of yellow and gold resulting from trace amounts of ammonia, methane, and water vapor. Beneath the visible cloud layers, the atmosphere transitions from gaseous to liquid metallic hydrogen due to the immense pressure. Saturn's surface, not solid but rather a dense core surrounded by layers of metallic hydrogen and helium, is hidden beneath these thick atmospheric layers. The planet's atmosphere also exhibits unique features like the Great White Spot, a massive, periodic storm, and a peculiar hexagonal cloud pattern at the North Pole. Internal structure. Saturn's internal structure is composed of several distinct layers. At its core lies a dense region of heavy elements, primarily iron, nickel, and silicate, with a mass estimated to be around 9 to 22 times that of Earth. Surrounding the core is a thick layer of metallic hydrogen, created under immense pressure where hydrogen atoms are compressed into a liquid state with metallic properties. Above this is a layer of liquid hydrogen mixed with helium, transitioning gradually from the metallic hydrogen layer. The outermost layer consists of gaseous hydrogen and helium, forming the visible atmosphere with its distinctive cloud bands and dynamic weather systems. This internal composition, with its layers of increasing pressure and temperature, contributes to Saturn's strong magnetic field and overall low density, making it the least dense planet in the solar system. Magnetic field. Saturn possesses a powerful magnetic field, approximately 578 times stronger than Earth's. This magnetic field is created by the movement of metallic hydrogen inside the planet. Interestingly, Saturn's magnetic field is almost parallel to its rotation axis, a distinctive characteristic compared to other gas giants. Similar to Earth, Saturn's magnetic field exhibits a dipolar structure with both north and south magnetic poles. Saturn's magnetic field, known as its magnetosphere, stretches extensively into space, encompassing its rings and a number of its moons. This magnetic field's dimensions vary in reaction to the pressure of the solar wind, expanding to cover millions of kilometers from the planet. This area traps charged particles, forming powerful radiation belts. Rings. Saturn's rings are one of the most iconic and visually stunning features in the solar system. Composed primarily of countless small particles of ice and rock, ranging in size from microscopic dust grains to boulders several meters across, the rings form an extensive, flat disk around the planet. The rings are divided into 7 main sections named alphabetically in the order of their discovery, D, C, B, A, F, G, and E rings, with the A and B rings being the most prominent and separated by the Cassini division, a gap created by gravitational interactions with Saturn's moons. Ring structure. The ring structure is maintained by a complex interplay of gravitational forces, including those from Saturn's numerous moons, known as shepherd moons, which help confine the ring particles and shape the ring edges. The thickness of the rings is remarkably thin, only about 10 meters, 30 feet, on average, while their diameter spans up to 282,000 kilometers, 175,000 miles. The rings reflect a significant amount of sunlight, giving them their bright, shimmering appearance as seen from Earth. Saturn moons. Saturn has 146 known moons in orbit. The largest and most famous of these moons is Titan, which is also the second largest moon in the solar system after Jupiter's Ganymede. It has a dense atmosphere primarily composed of nitrogen and methane, and lakes of liquid methane and ethane. Enceladus, known for its geysers of water vapor and icy particles erupting from its south pole, suggesting the presence of a subsurface ocean. Mimas, notable for its large Herschel crater, which gives it a resemblance to the Death Star from Star Wars. Iapetus, known for its two-tone coloration, with one hemisphere being much darker than the other. Rhea, the second largest moon of Saturn and known for its heavily cratered surface. Dione, similar in size to Rhea, with wispy fractures on its surface caused by geological activity. Exploration. Pioneer missions. Pioneer 11, 1979 first spacecraft to fly by Saturn, providing initial close-up images. Voyager missions. Voyager 1 and 2, 1980 to 1981 provided detailed images and data on Saturn's atmosphere, rings, and moons. Cassini-Huygens mission. Cassini Orbiter, 1997 to 2017 extensive study of Saturn, its rings, and its moons, revolutionizing our understanding. Huygens probe, landed on Titan, providing first direct data from its surface. Thank you for watching us. Please like, share and subscribe our channel Little Shaver World.